What is going on, guys? Welcome to this Python tutorial series for intermediates. In today's video, we're getting deeper into multi-threading, and we're going to talk about the synchronization of threads. How to use multiple threads at once that try to access the same resource. How do we manage that? How do we ensure that there are not any problems, that we don't get any errors there? Because imagine you have 10 threads accessing some kind of resource. That might be a RESTful web API, that might be a list of numbers, that might be, I don't know, a string, just a simple resource, and multiple threads are trying to change that resource to access that resource at the same time. And one guy is changing it, another guy is reading it, and that might lead to some problems, of course. So we are going to prevent that with synchronization. We're going to look at different types of locking and semaphores and so on. So let us get into the code. Now, the first concept that we're going to talk about is locking. And to show you how locking works, I'm going to give you a very trivial example once again. So nothing you would ever need in programming, nothing you would ever do that way, but it shows you how locking works and why it might be useful in some other places. So what we're going to do basically is we're going to have a shared resource, just a number, which is a power of 2, and we're going to have two threads. One thread is going to double the number, and one thread is going to divide the number by 2. So basically they're counteracting each other, and our goal is to get to a certain maximum value or a certain minimum value, but we're not going to get there because, you know, the threads are counteracting each other. So this is a problem. And then we're going to lock the resource to see how you might let one thread get to the maximum number and then let the other thread get to the minimum number, for example. So for this, we are going to import, first of all, the threading module and also the time module. Now I'm going to explain in a second why we need time, or the time module, because we're going to use a method from the time module, but for now just import it and we're going to see where it takes us. Now, first of all, let's define a resource x equals, I set a power of 2, so let's say 8,192. I think that is a power of 2. And what we're going to do now is we're going to define two functions. The one function is called half and the other function is called double. Of course, because we're always multiplying by 2 and dividing by 2. So I can say def double, and I take no parameters, but I say global x. We need to use the global keyword here because global always says I have a variable in my script that's not part of this function, but still I want to access that particular value, so I want to also change it. And to do that, I need to define this variable as a global variable. Otherwise, I cannot manipulate it. So what I'm doing is I say global x, and then what I do is I just say x times equals 2, and I have to say while x is less than, let's say, what is the next power of 2? I think 16,384. And when I say while x is less than this number, so the double, or the x amount times 2, as long as it's not that, I'm going to double the number, so times equals 2. And then I'm going to use the sleep method of time. This is why we need the time module. And this sleep method tells our program to just wait for X amount of seconds. In this case, I'm going to say wait for 1 second. And I'm doing this so that we can somehow track what's happening. It's not really useful for the script, but we're going to do this so that we can see what happens, because we're going to do this with both functions. And if we don't use the sleep method, we're just going to execute everything in milliseconds, and we're not going to be able to track what happens. So then I say, after that, I say print reached the maximum. And when I have this, I can now define the second function, which is half. And here I do the same thing, just the other way around. So while x is greater than 1, I say x divided equals 2 time dot sleep 1. Now, what I need to do now, of course, is I need to run two threads that execute both functions at the same time, because I cannot just call both functions in my script without threading, because it would execute one and then the other function. So to do that here, I just have to say t1 equals threading dot thread with a target function of half, and t2 equals threading dot thread with a target function of double. And then I say t1 dot start, t2 dot start. So when we run that, we actually need to print the value first because we're not seeing what happens. So what I'm going to do is I'm going to always print x in both functions. So print x so that we can track what happens here. So you see basically what happens is one thread is trying to divide a number by 2, the other one is again doubling it, so they're in an endless loop because they're always doing the same shit. So we're not getting anywhere near the maximum or the minimum. We're always staying at these two numbers. And of course, in this case, it doesn't make sense because what we actually do here when we try to lock the resource is we're using multi-threading to execute the two things at the same time, and then we're using locking to do it serially again. So why use threading in the first place? As I said, this is a trivial example. We don't really need it, but it shows you how locking works. So imagine X is a resource, is our resource that we want to access with multiple threads, and what we're going to do now is we're going to define a so-called lock. And this lock is part of the threading module. So we're going to say threading.lock to define this lock. And this lock is going to allow us or forbid us to access the resource. So whenever I want to access my resource, I have to first lock it, to try to lock it. If it's locked already, I cannot lock it because someone else has locked it. So of course, first of all, I need to make this lock global so that I can use it in my function. But then before I do anything else, I use the lock.acquire method. So lock.acquire acquire. And this tries to acquire the lock if it's free. If it's not free, we're just waiting here. So if this function here or another thread already locked the resource, we cannot lock it again. So we just wait until it's free. And if it's free, we lock it, of course. So once it's locked, we do all this. And then when we're done with that, when we say reach the maximum, at the end, we're going to say lock.release. And we're going to do the same thing in this function. So lock, the first thing is lock.acquire. And the last thing, oh, here we forgot to print reached the minimum and lock.release. Now what happens now is the first function that gets executed will lock the resource. In this case, it's the half function, and it's going to do everything until it gets to the value 1, its minimum value. And then once it's there, it's going to release the lock and the other thread is going to start, as you can see, until it gets to the maximum value. So basically only one thread at a time can access the resource. As you can see, we're there. So this is basically how locking works. Now, another very useful way to limit the access to a resource is through so-called semaphores. These do not lock the resource completely, but they limit the access to the resource through a maximum value. So we say we only allow 5 accesses and not more than that. So multiple threads can access a resource, but not unlimited. So how we do that is we first of all define a semaphore, which is also part of the threading module. So we say threading.bounded semaphore. And now we are going to specify a value. This will be the maximum value of accesses allowed. So in this case, let's just say we allow for 5 accesses. And the next thing that we're going to do is we're going to define a basic function that tries to access a resource. So let's just say access, and what we're going to pass here is we're going to pass some form of identification, because we're going to run 10 threads and we're going to have all of these threads numerated or indexed with a number. So we're going to have thread 0, thread 1, thread 2, and so on, so that we know which thread is trying to access right now and which thread is locking, which thread is releasing, and so on. So we're going to pass a thread number so that we know which thread is trying to access right now. And what we're going to do then is we're going to just print a message which says thread number, and this thread number is trying to access, just like that. And of course we have to format in the thread number, and after that we're going to try to acquire a semaphore, or basically to acquire the semaphore. And if we haven't had 5 accesses already, or if it's not already 5 times acquired without having been released, we'll get access, or will be granted access to the resource. So we're going to say semaphore dot acquire, and if this works, we're going to print thread number was granted access dot format thread number. And now we're going to just wait for 5 seconds. So we're going to keep this acquired for 5 seconds, and then we're going to print, okay, now, or thread number is now releasing dot format thread number. And then we're going to say semaphore dot release. So I think that's it. Now, what we're doing now is we're going to make a loop, a for loop of 10, or with 10 iterations, and we're going to create 10 threads that are all going to execute this function with a different thread number. So we're going to say for thread number in range 10. If you want to start counting at 1, you can also say from 1 up until 11. And we're going to say t equals threading dot thread, and we're going to specify as a target function the access function. And now we have to pass a parameter, which is the thread number. So we do this by specifying the args keyword. We're going to say args equals, and then we're going to pass the thread number with a comma, like that. So this is how we specify a new, or this is how we pass the parameters into this function here. And then we're going to say thread.start. And maybe we're going to just wait every time 1 second so that we have a better overview. And when I now run this, you'll see that 1 is trying to access 2, 3, 4, 5, or actually this is quite stupid because now I'm not waiting enough, but let's say we wait for 10 seconds, like that. Now 1 is accessing, 2 is accessing, 3 is accessing, 4 is accessing, 5 is accessing, and now 6 is trying to access, and all of them are trying to access, but they don't get the access until I release. So you can see that 6 was granted access when 1 released, and it was already filled up, the semaphore was already acquired. And this is the reason why 6 did not or wasn't granted access immediately. 7 wasn't granted access immediately. They had to wait for other threads to release the lock. So this is how this works. So that's it about synchronizing threads. I hope you learned something. I hope you enjoyed the video. If so, hit the like button, ask questions, and give feedback in the comment section down below. Subscribe to this channel if you want to see more. Keep watching the videos. Stay tuned. And thank you very much for watching. See you in the next video. Bye.